So, we are discussing about the subject signals and systems. In the last few lectures we talked about the definition of signal, the definition of system, few fundamental continuous time signals, few fundamental discrete time signals. Today I am going to discuss mathematical operations performed on a signal. Few mathematical operations we have to know. Number 1 is time shifting, number 2 is amplitude shifting, number 3 time scaling, number 4 amplitude scaling, then time reversal or folding or reflection, number 6 is signal addition, number 7 is signal multiplication. So, the first topic is time shifting. In this case, with respect to the time axis, we have to shift. Sometimes it is required to shift the signal, it may be in the left hand side, it may be in the right hand side. So, shifted version, let x t is any continuous time signal. So, shifted version of this x t is represented by x t minus m. Now, depending on the sign of the m, the signal may be shifted in the right hand side or may be shifted in the left hand side. If the sign of the m is positive, so there is a right shift of the signal in the time axis. This signal is the delayed version of the signal. This is the delayed signal, and if m is negative, then there is a shift in the left hand side, it is advanced signal, shift in the, so here it is right hand shift, here it is left hand shift. So, this is the advanced signal. So, in the both cases, so x t is the original signal, if m is positive there is a shift in the right hand side, so it is the delayed version of the signal. So, x t minus m. If a is negative, m is negative, then it is plus. So, actually x t minus of minus m is negative, sign of the m is negative. So, there is a shift in the left hand side. So, it is the advanced signal, but 3 of the cases it should maintain the same shape, the shape of the signal will be same, but there is a shift in the x axis, in the time axis, that is x axis. So, it may be left hand side shift, it may be right hand side shift. Let us consider one example. Let us consider x t is a signal, this amplitude is 1, this is minus 1, this is plus 1, t is equal to 0, this is time axis. Okay. So, we want to find out x t minus 1. So, here m is positive, there is a shift in the right hand side, this is the delayed version of the original signal. So, now the signal is okay. So, this is the signal. So, this is x t minus 1. So, it is there is a shift in the right hand side. Now, this with respect to the original signal, it is in the right hand side with respect to this axis, in the this t is equal to in the t axis, and there is a shift with respect to this t is equal to 0. Now, if you consider m as negative, then what will happen? If m is negative, so it is 0, it is minus 1, it is minus 2, plus 1, plus 2, this is t axis, this is t axis, this value is equal to 1. So, here it is x t plus 1. Okay. So, value of m, here m is negative. So, x t of minus 1, okay, that is x of t plus 1. So, when m is negative, there is a shift in the left hand side in time axis with respect to t is equal to 0. Okay. Now, it is left handed signal with respect to the original signal. So, this is the time shifting operation. So, according to our requirement, we can shift the signal in the left hand side or in the right hand side. If it is in the right hand side, if we shift in the right hand side, so it is the delayed version of the original signal. If it is in the left hand side, so it is the advanced version of the original signal. Now, number 2 operations, that is amplitude shifting. Number 2 is amplitude shifting. So, previous one was a shift in time axis. Now, we want to shift in the amplitude axis. Let x t is any given continuous time signal, and we want to shift it in towards the amplitude axis. So, if there is a shift in the amplitude axis, the shifting parameter is k. It is represented as x t plus k. Okay. So, x t is the original signal, there is a shift, amplitude shifting. Now, it is x t plus k, k is the amount of shift. Now, it depends on the sign of the k, whether it is shifted upwards or downwards in the amplitude axis. If k is positive, then there is a shift in the upward. If k is negative, there is a shift in downwards. Okay. Now, let us consider example. So, this is t axis minus 1 plus 1, this value is 1, this is x t. So, this is our given continuous time signal x t. Now, we will check the amplitude shifting property. Let we want to shift it in the upward. So, x t plus m. Okay. So, if x t plus m, so this value is 1, this value is 2. Okay. There is a shift in the upward side. This is the original signal. Now, x t plus 1, it is shifted upward, that is now this is the signal, it is shifted upward. Now, consider x t minus 1, this is 0, t axis, this axis is t axis, plus 1 minus 1 plus 1. So, original signal is here, this is the original signal, but x t minus 1 will be downward. So, now this is the x t minus 1 signal, this is minus 1, this point is minus 1. So, here when we are talking about amplitude shifting, it may be upward, it may be downward, okay, in the y axis, that is amplitude axis. So, original signal x t, it is shifted upward up to unit 1, so it is shifted upward, so x t plus 1, when it is shifted downward x t minus 1. So, this is amplitude shifting property.